Alright, hello Algebra 2. So today we're looking at the binomial theorem, and I know it says theorem, don't freak out, we're not going to have to prove it. So that's just what it's called, the binomial theorem. And binomials, remember, are things where we have two terms. So if I just get something like a 3x squared, that's a monomial. A binomial is if I throw like a plus a 2x. So anything with two terms there, that's a binomial. So two terms there. So this is the binomial theorem. But in order to look at that, first we're going to look at a thing called Pascal's triangle, which may or may not be something you've seen before. So this is Pascal's, might have popped up in science, Pascal's triangle. And what's going on with this triangle is if you take a row, each of these numbers is coming from adding the two numbers above it diagonally. So like 4 and 6 give you 10. 4 and 1 give you 5. So if we want to find, say, the next row, there's always 1s on the end. So 1 and 5 gives you 6, 5 and 10 gives you 15, 10 and 10 gives you 20, 10 and 5 gives you 15, 6 and 1, and you may notice it's symmetrical, so these numbers are repeating. So we got 15s, 6s, 1s, so it should be the same on both sides. Now, you're not going to have to go through and find a bunch of rows of these triangles. I included in the video description a link to a site that has like the first 15, 16 rows. You shouldn't need more than that. If for some reason the link doesn't work on your computer, because I don't know what is and isn't blocked on the Chromebooks, just Google Pascal's triangle first, however many rows you need, and it'll give you that, so you don't have to go through and find those, because these numbers get big pretty quick. So we're not going to have to go through and find all your rows of your triangles. Now, what this is good for is if we have a binomial and we're expanding it. Turns out that if we're taking something to the fifth power, your coefficients, or the numbers in front of your variables, end up being the same as the fifth row of your triangle if you're counting this as row 0. So this is like row 0. This is actually the first row, second row, third row, fourth row, fifth row. And if you get to like the 14th row and you're not sure whether the 14th or 15th, it should be the same as your second number here. So this is a 5, so this is the fifth row. That's a 6, so that's the 6th row. So I'm going to take that 1, 5, 10, 10, 5, 1. 1, 5, 10, 10, 5, 1. And what those are going to do is those are going to be our coefficients outside of our terms. And now, the biggest x I'm going to end up with is an x to the 5th. So I'm going to start with an x to the 5th. And then I'm just going to count down in order. So we're going to have an x to the 4th, an x to the 3rd, an x squared, an x, and then this one doesn't get an x. And then we're going to go the other way. So we're going to start over here and say this one gets a y to the 5th, this one gets a y to the 4th, that one gets a y to the 3rd, that one gets a y squared, that one just gets a y, that one doesn't get a y. Cool. Now, really the only thing to watch out for is if that's a minus instead of a plus, your things alternate. So this would be a minus, that'd be a plus, minus, plus, minus. Okay, so that's how you expand a binomial using this. Now, most of them we're not going to go through and do the whole thing, because again, if you're looking for something to the 8th or the 9th power, these get long pretty quick. This was almost going off my whiteboard as is. Most of the time, what you're going to be looking for is just like your 5th term, or your 7th term, or your 9th term. So if we want the 7th term of this, the only thing I'm interested in is what's that 7th number of my 9th row of Pascal's triangle. And I forgot to keep that up on my screen here. So if you're looking at the 9th row of Pascal's triangle, your numbers are going 1, 9, 36, 84, 126, 126, and then they repeat 84, 36, 9, and 1. And this is why we're not going through and writing out the whole thing, because even those numbers are going off my little whiteboard. So what we're really interested in is the 7th term there. So 1, 2, 3, 4, 5, 6, 7. We want that 84. So it's going to have an 84 in front of it. But instead of just an x or something to the 7th, so normally we would have like an x to the 7th. Wait, no, 9th, because we're starting with 9. 9th, 8th, 7th, 6th, 5th, 4th, 3rd. So we're going to have an x to the 3rd, but our first term isn't just an x. It's a 2x. So we're going to have a 2x to the 3rd. And we're going to have a 3y to the, and we're counting backwards, so 9, 8, 7, 6. And your two numbers here should always add up to 9. So the number that goes with the first term and then the number that goes with the second term, those should add up to 9. And then I should have left myself some more room there, because now we're going to take that and we're going to simplify that. Hang on. Okay, so now we've got this. So now we're going to take that 84 times our 2x to the 3rd, and watch out for exponents first. So 2 to the 3rd power is 8, and that gets an x to the 3rd. And then 3 to the 6th is, should grab my calculator, 3 to the 6th is, 3 to the 6th is 729. And that gets a y to the 6th. And then we're taking 84 times 8 times 729, so 84 times 8 times 729 gives you a really big number, 489,888, and that's still got an x to the 3rd and a y to the 6th with it. So that whole thing is your 7th term, which is why we're not going to go through and find the entire expanded binomial, because that would be long and that would be messy and that would go off all of my whiteboards. Okay, let's do one more though. So let's say we want the 6th term of 3x minus 5 to the 8th. So again, really the only term we're interested in there is if we go 1, 2, 3, 4, 5, 6. So that's a 56. And then if we're counting down, we're going to have an 8th to the 7th to the 6th to the 5th to the 4th to the 3rd. We're going to have this term to the 3rd. Oops. This term, not that term. 3x to the 3rd, and we're going to have a, watch out for that minus goes with the 5, which is why some of your things end up plus and minus when you've got a minus there. So you got a negative 5 to the 8th, 7th, 6th, 5th. So again, these two numbers should add up to this thing. Okay, so now we've got exponents first, so 3x to the 3rd gives us a, we still got a 56 here. 3 to the 3rd is 27. Oops, that was an underline, not a minus sign. I should be careful with that. And negative 5 to the 5th is, 5 to the 5th is 3,125, but that's negative. Okay, so now we got that. So now we're taking that negative 3,125 times our 27 times 56, which gives you a really big number. Negative 4,725,000. And that's still got an x to the 3rd. Now you may notice at the end that one didn't end up with anything to the 5th at the end, and that's because the only thing we were taking to the 5th there was just a number. That was just a negative 5 to the 5th, so that exponent disappeared. So it's okay if that happens when one of your terms of your binomial is just a number. Now, lots of numbers, and you're probably wondering, Miss B, what is this actually good for? This is one of those things that is actually good for something. So what this is actually good for is if we get into some stuff with probability. And I want to know, if I flip a coin 5 times, we want the probability of getting heads exactly twice. So and assuming here that, we're flipping a fair coin, we're equally likely to get heads and tails. Now, a number like 5, you could go through and just write out all your possibilities. So I could have heads and heads and heads and heads and heads. I could have heads and heads and heads and tails. But 5 is getting up there where you might not want to do that, and anything bigger than that, you're definitely not going to want to do that. So, what we actually want to do is our 5th row of Pascal's triangle looks like this. And if we say we're expanding H and T for heads and tails, what this actually gives you is the probability of getting all heads and 4 heads and 1 tail, 3 heads and 2 tails, 2 heads and 3 tails, 1 head and 4 tails, and all tails. So if you find all of your possibilities, you got one of them that is 5, 10, 10, 5, and 1. So then if we want the probability of getting heads exactly twice, the one we're interested in is the one where we have heads twice. So that's 10 different ways we can get that out of, and now we just want to know how many total possibilities do we have. So 10 and 10 is 20, another 10 gives you 30, so 32. And feel free to plug this into your calculator and add them up that way, especially if the numbers are big in this. This one you could probably do in your head. If you get to something like the 12th row, you probably don't want to do that. Okay, so 10 out of 32, or if you want to reduce that, we get 5 out of 16, or if you want that as a decimal, because you like decimals, 5 out of 16 is 0.3125, so about 31%. So we got about a 31% chance of getting heads exactly twice. So, I mean, not too bad. Now, you may notice we would have gotten the same thing if we said instead of heads and tails, we're going to call this tails plus heads. So if you flip-flop those around, and if this was 2 heads instead, you actually end up with exactly the same number, which kind of makes sense. We got the same odds of getting exactly 2 heads as we do of getting exactly 2 tails, because our probabilities are the same. So again, we're assuming we're equally likely to get heads as we are to get tails. Okay. Last one. So let's say we've got a class of 14 and we want to find the probability of having exactly 5 girls in that class. So not like at least 5, just exactly 5. So again, it doesn't matter whether you're going through and calling the first one girls and saying I've got girls plus boys, or if you're saying boys plus girls. You're either looking for the 5th term going this way will give you 5 girls, so 1, 2, 3, 4, 5. Or if you count backwards and go, well, I got 1, 2, 3, 4, 5, you get the same number. You get to that 1001. And you may notice I went through and wrote out the 14th row of Pascal's triangle for you, because those are lots of numbers. Okay, so we've got 1001. Either way, whether it's this 1001 or this 1001, it doesn't matter, because again, we're assuming here that you're equally likely to have a girl or a boy. Now, technically, those probabilities might vary a little bit, but they're close enough that for these purposes, we can just call it half and half. Close enough. Okay, so we've got our 1001, and then we just want to know out of how many possibilities. Now, just a heads up that when you're going through and adding these up, instead of adding up all of them, if I go like 1 plus 14 plus 91 plus 364 plus my 1001 plus a 2002 plus a 3003. And I'm going to leave off that 3,432 for the moment, because all of these are repeats. So if I've got all of these, I can just take that times 2, and that takes care of all of these. So I'm going to hit equals and then take it times 2. Now, if you're doing that, make sure you hit enter or equals or whatever your button is before you take it times 2, because otherwise it'll do order of operations and just take the last thing times 2. That's not what you want it to do. Okay, and then we're going to add in that 3,432. And as long as I didn't hit any buttons wrong, that should be around 16,384. I would just leave that as a fraction, because it's not going to come out to a nice decimal. But if you really, really, really like decimals, 1, 6, 3, gives you about 6%, about 0.06109, about 6%, which sounds about right, because in general, if you have 14 people, you're probably going to have more than 5 girls, because half would be 7, so that's quite a bit less than half, so 5 and 9 split, not too likely there. I mean, it can happen. 6% is a thing that can happen, but not terribly likely to happen there. Okay, so that's what's going on with those. And again, we're assuming that that's half and half. So these get kind of long, which is why if you're looking at the numbers, you may notice there are a few less than 10. So that's why. Go ahead and check out the numbers in the description below, and I'll see you in the next video.